Welcome to the lecture number 71. Problem set 3, circle. Now you will find figure is given. This figure is on page number 87. Figure is 3.91. Now there are 5 questions based on this figure, and I would say it's a very typical question for 4 marks. Because 1, 2, 3, 4, 5. If any one of these questions can be dropped, this question can be there for 4 marks. Only I would like to explain at the beginning that AS is not a diameter at all. Points S is somewhere here. Okay, so this is a figure, and on the basis of this figure we have to answer the following things. The first one is, what is sum of angle TAQ plus angle TSQ? You will find quadrilateral TAQS is a cyclic. So quadrilateral TAQS is cyclic. If this is a cyclic quadrilateral, then angle TAQ plus angle TSQ is equal to 180. Opposite angles. Opposite angles of cyclic quadrilateral are supplementary. Try to understand again. Angle TAQ, this whole angle, and angle TSQ, this whole angle. Sum of these opposite angles is 180. TAQS is a cyclic quadrilateral. Second question is angles congruent to angle AQP. Now AQP is this angle. Angle AQP, PQ is a tangent while AQ is a secant, and vertex is lying on the circle. Therefore, angle AQP is equal to, second one, angle AQP is equal to half measure arm angle AQP is equal to half measure arm AQ, half measure arm. Reason is tangent secant theorem. Tangent secant theorem. Second one is, please try to understand, angle ATQ, this angle. Vertex of the angle is on the circle. So angle ATQ is called as inscribed angle, and measure of an inscribed angle is always equal to half the intercepted arc. So you will find here angle ATQ is also equals to half measure arm AQ, inscribed angle. Angle AQP is equal to half RAQ because it is secant, this is tangent. So by tangent, secant, angle here. Angle ATQ, vertex of the angle is on the circle. Therefore, angle ATQ is called as inscribed angle. Measure of the inscribed angle is equal to half the intercepted arc. So that is also equals to half AQ. Now next to that you will find angle ASQ. Try to understand. Angle ASQ. This is also inscribed angle, and measure of this angle is also equals to half arc. So angle ASQ, angle ASQ is equal to half measure arc AQ. Reason is same, incident angle. So therefore, angle AQP is equal to half arc AQ. Angle ATQ, angle ATQ is also equals to half arc AQ, as well as angle ASQ is also equals to half arc AQ. So this is how you will find. Question asked is find out the angles congruent with angle AQP. So we got angle AQP, angle ATQ and angle ASQ. All these three angles are congruent because measure of each one of them is equal to half measure on AQ, intercepted arc. For these two angles, reason is inscribed angle, but for this AQP, reason is tangent secant angle. Okay. Now third one is, the third sub question is angles congruent to angle QTS. This is QTS, this angle. So angle QTS is equal to angle QTS is equal to half measure arc. Angle QTS, this is inscribed angle and this two sides are there, PQ and TS. So opposite arc, which is called as intercepted arc. So you will find angle QTS is equal to half measure arc QS. Half measure arc QS. Inscribed angle. So this is inscribed angle. This is inscribed angle, angle QTS. Now next to that, you will also find, please try to understand, angle, okay, angle SAQ, angle SAQ. This angle vertex is on the circle. This is also inscribed angle, so that is also equals to half arc SQ. So angle SAQ, angle SAQ, that is also equals to half measure arc QS. Reason is same, that is inscribed angle. Inscribed angle. Please try to understand. Angle SQR. Angle SQR, you will notice SQ is secant and QR is tangent. So by tangent secant angle theorem, angle SQR, that is equal to half arc SQ. So angle SQR is equal to half measure arc QS. Tangent secant angle theorem. So this is how here answer is ready, that angle QTS, angle QTS is equal to, angle QTS is equal to angle SQ. That is equal to angle SQR. So you will find that QTS is half measure arc QS inscribed angle, SAQ is equal to half measure arc QS inscribed angle, but angle SQR is equal to half arc QS, that is tangent secant angle. So here we finish third questions. Now fourth one is, if angle TAS, answer 1. If angle TAS, this angle is 65. If angle TAS is 65, find angle TQS. Angle TQS. Now angle TQS has intersected on TS. Angle TAS has also intersected on TS. Both of them are called as angles inscribed in the same arm. They are called as angles inscribed in the same arm. So here we write angle TAS. Angle TAS is equal to angle TQS. That is equal to 65. Angles inscribed in the same arm. Angles inscribed in the same arm. Not only that, but we also have to find out RTS. Now we find that RTS is intersected by angle TAS as well as TQS, and this is inscribed angle which is half the measure of RTS, or we can say measure RTS is twice the angle TAS. Try to understand the inscribed angle once again. The measure of RTS is twice the angle TAS, or angle TAS is half the RTS. So measure RTS is equal to is 2 into is equal to 2 into angle TAS. That is equal to 2 into 65 is 130. That is equal to 130. So this is a question number 5. Question number 5. Now next to that is question 5, which they ask us if angle AQP is 42. Angle AQP, okay. If this is 42. Angle AQP is 42. Angle SQR, okay. Angle SQR is given as SQR is 58. Then they ask us to find out angle ATS. ATS. Okay, try to understand now. We have to get angle ATS. Fine. To get angle ATS, now you will find angle ATS and this angle. These two angles must be supplementary angles. Try to understand. Angle ATS and angle AQS are supplementary. Angle AQS, this total angle is 180. This total angle is 180. So first of all, I will find angle AQS. Angle AQS is equal to angle AQS is equal to 180 minus 42 plus 58. 42 plus 58. That will give us 180 minus so that is equal to 80. So angle AQS, we don't have to find out AQS. Try to understand. We don't have to find out AQS. Our question is to get angle ATS. But if you get this angle as 80, because sum of all angles in a linear pair is 1. Angles in a linear pair. Angles in a linear pair. So it is very important to get angle AQS, which is 80. But angle AQS and angle AQS are supplementary. Why they are supplementary? Because quadrilateral ATS2 is cyclic, and opposite angles of cyclic quadrilateral are always supplementary. If this is 80, this has to be 100. So I am writing angle ATS is equal to 180 minus 80, and that is equal to 100. That is equal to 100. So very, very important thing, that angle ATS is equal to 100. Angle ATS and angle AQS opposite angles of cyclic quadrilateral. Cyclic quadrilateral ATS2 supplementary. Okay. So please try to understand. It's a very big question. Okay, very big question. So first question is TAQ plus TSQ. TAQ, this angle, plus TSQ, they are opposite angles of cyclic quadrilateral ATS2. Therefore, they are supplementary. Answer of 1. Second one is angle is congruent with AQP. So angle AQP is equal to half arc AQ. So this angle is same as this angle, that is angle ATQ. But angle ATQ and angle ASQ are also same, because each one of them is equal to half arc AQ. So that is what I am writing. AQP is equal to ATQ is equal to ASQ. Next to that, angles congruent with angle QTS. Okay, QTS. So QTS is equal to half arc QS. So likewise, SQR is also equals to half arc QS. But reason is tangent secant angle. Okay, tangent secant angle here. And third angle is angle SAQ. Angle SAQ is inscribed diagonal, and that is also equals to half arc QS. So here you will find QTS is equal to SA is equal to SQR. Each one of them is equal to half arc QS. Then next to that, angle TAS is equal to 65. Okay. Angle TAS. Angle TAS. This angle is given as 65. Next to that, which else angle is 65? So TQS. TQS is also 65. TAS is also 65. TAS, because angle TAS is equal to half arc TS. As well as you find angle TQS is also equals to half arc QS. So this is how you will be getting angle TAS is equal to angle TQS, that is equal to 65. Angles inscribed in the same arc. Now, if we say intercepted arc is twice the measure of inscribed angle, or inscribed angle is half the measure of intercepted arc. So TS is equal to twice of 65. So you will be getting it as 130. Next to that, this angle is given 58. This is given as 42. So these all angles are angles in the linear pair. So AQS is equal to 180 minus 58 plus 42. 58 plus 42 is 100. 180 minus 100 will give us angle AQS as 80. If angle AQS is 80, then opposite angles opposite angles on cyclic quadrilateral are supplementary. Therefore, you will get angle ATS as 100. So here this question finished. Let's do the next.